In this video, we're going to take a look at how to find the mean or the expected value for continuous random variables. For this function, we're looking at a function that can take answers somewhere between, input somewhere between 1 and 5. And if I've just done a quick sketch of this, you're not asked to sketch it, we're just asked to find the expected value or the average. But if we do look at the diagram, we know that when we, so imagine if we rolled the spinner or whatever this was, we're going to get numbers somewhere in between 1 and 5. So when we get the average, I would hope that the answer is somewhere in between 1 and 5. And actually, if you just look at it, as we go higher, as we get closer to 5, the area gets a bit bigger. So it's like more likely to get numbers up here, less likely to get numbers down here. So I think the average is going to be around about somewhere a little bit bigger than 3. And you don't need to do this, but it's nice to give you a feel for the answer. Like, I would expect the average to be somewhere around about here. Okay. It's similar to the median, but it's not the same as the median. It's not necessarily smack bang in the middle, like with 50% one side, 50% the other side. This is an interval that we have to calculate. And if you want the expected value of x, the formula looks like this. We multiply by x before we integrate. So we'll set up an integral. We're going to integrate. This function is defined between 1 and 5. The function is 1 over 40. X plus 7. I've seen people do this in the past, right? If we just actually integrate the function between 1 and 5, do you know what the answer would be? The answer would just be 1. Like if we don't multiply by x, because I've seen people forget to do this. If you don't multiply by x, all you're doing is you're working out this area here, which is not what we're being asked. If you want the expected value of x, we multiply by x before we integrate. Okay, and this is going to tell me the average outcome. It's almost like with the discrete ones, you times by x with the probabilities, and then you add them all up. Because this is continuous, this is sort of like the continuous way of doing that. You times the outcomes by the outcomes by the probability, which is the function. There is a parallel between the two things. Like for the discrete, it was the sum of x times by the probability. But because this is continuous, we integrate to find the sum, x times by the probability. Okay. Not necessarily that you can see that link, but I just think it maybe helps you to remember some of these because they're quite similar for discrete and for continuous. So I'm going to integrate this. Because there's the 1 over 40, it's all times by 1 over 40. Just take that outside, get out of the way. Okay. And then we've got x times by x plus 7. So I'm integrating x squared. Remember, before you integrate, always get it into index form. Okay. Add 1 to the power. Divide by the new power. And then sub your limits in. Don't forget your negative with the bracket. Okay, so obviously we can work this out in the calculator, but we could also just, if we're confident in our technique here, or if we just want to check our answer if we've got enough time, we can set up an integral. So we're going to integrate 1 over 40 x squared plus 7x. And then the limits are 1 and 5. And I get 47 over 15. Which, yeah, there we go. 3.13 ... Obviously, it's better to leave it as an exact fraction. If you are going to write it as a decimal, I would always use at least 4 significant figures. Okay, and again, does that seem like a sensible answer? The average outcome, we know it's going to be somewhere in between 1 and 5. So it looks good to me. Example 2, we've got the function defined for like two separate parts. So between -8 and 0, it's 1/12. And then between 0 and 2, it's this quadratic. You don't need to draw this unless you're asked to. I would obviously, in the exam, I would always draw it, especially if probabilities are involved. But this one's just the mean. I'll show you what it looks like though, just for reference. So between -8 and 0, we've got a constant 1/12. And then between 0 and 2, we've got a positive quadratic. If I sub 0 into this, we get 4/48, which is a 12th. So that means where this one finishes, this one starts. And then if I sub 2 in, I get 4, 12, 16, 16, I get a third, I think. So it's a positive quadratic. And it goes up to a third. Okay, not necessary for this specific question, like we just want to figure out what the mean is. But the average, hopefully we'd agree, like the average outcome is, I think it's going to be somewhere around about here. Like, you're going to get, there's a good, it's a fairly consistent probability of you getting outcomes around here. There's a slightly bigger chance of you getting like a 1 or a 1.5. But overall, the average is going to be, because we do get quite a lot of negative answers, don't we? The average is going to be somewhere around about here. Okay, but importantly to actually do the calculation, because there are two separate functions, we have to do two separate integrals. So for this first one, we're going to integrate between -8 and 0. 1/12. Don't forget, we want the expected value of t. So before we integrate, we have to multiply by t. Please don't forget to do that. And obviously, because this is with respect to t, we're going to multiply by t. If it was x's, we'd multiply by x. Plus the next one, which is between 0 and 2. So all we do when there's two separate ones, we just integrate them both times by t and add the answer together for the average. Okay. For this one, we got 1/48. Multiply by t as well. And then that'll be 3t squared plus 4. With this being a show question, obviously we have to set this out carefully. We could probably use the calculator at the end to check. So we're going to maybe do two separate integrals. There's going to be a lot going on. I don't know if I've got enough space here. We've got 1/12 t squared over 2. Limits for that one. 0 and -8. I'll work that one out in a second. Thinking about this one, I'm going to take the 1/48 outside. Don't do too much at once here. This would be worth quite a lot of marks, this question. Before I integrate, let's just get index form. So that would be 3 t cubed plus 4t. Limit 0 and 2. Add 1 to the power. Divide by the new power. Okay. You guys will see that. So for the first one, when we sub 0 in, we'll get 0 minus and I'm going to do it on another line. I don't need an equal sign. So this and then plus, we're going to do 1/48. Open up a big bracket. We'll sub 2 in. Minus, when we sub 0 into this stuff, because it's all t's and t squared, that bit would just disappear, wouldn't it? Okay. Okay, so for that bit there, just be careful, that negative squared is positive. and then you subtract it, so that's minus 8 over 3, and then we've got 1 over 48 times by this stuff, which is 20. Okay, so if we do 20 times by 1 over 48, I've got that there, which is 5/12, and this, which is minus 8/3, which is minus 9 over 4, which is minus 2.25, which thankfully is what we were asked to find, because I didn't want to do that again. That was a lot of integration. I don't know if we're going to get one with as much integration as this, with it being just like the first year course, but it's a good one for us to look at, isn't it? Because like if we can do this one, we can pretty much hopefully answer any one of these that were asked in the exam. Just don't forget, if it's in 2 separate parts, you have to times by t and do them both separately and then just add them together. Okay, thanks guys.